Hello everyone, welcome to Unshackling Sudokus and Puzzles. Today's video will be on a classic Sudoku. As usual, the classic Sudoku train continues. Thanks for the tremendous support you guys have been showing for the last few videos. The views have been over the moon and we are really happy that you're enjoying these videos. Please do remember to subscribe to the channel so that you don't miss any video from us in the future. So actually, this was not the Sudoku I was planning to do today. I was planning to do a video on a Sudoku by Radar Village. It's called Excalibur. But to be honest, I got stuck on the Sudoku and I had to seek the help of the author. And during chat with him, I learnt of a new technique. Probably not new to many of our viewers. Maybe you guys might have seen it already somewhere else. It's called the tri-value ordogan or Thor's hammer. That was the first time I was hearing that technique, and I was really fascinated by that. I saw a discussion on it in the new Sudoku forum. So I thought of making a video on it, but I felt that I really need to make a bit of a research into the technique. First thing is, it's difficult to grasp the technique, and even if you grasp it, the next thing that will pose a challenge is explaining it to the viewers. It's kind of difficult, but hopefully one of these days myself or will be able to do a video on this. Let's see. But for today's video, we have an excellent Sudoku by the wonderful author Sulphur. Again, it's called Glacial Prison. It has a really narrow one step, which is not so easy to see. And if you find that step, you can get to the end of the Sudoku easily. So let's start the Sudoku now. Classic rules apply. Each row, each column and 3x3 box in the grid has digits 1 to 9 without any repetitions. So let's start the Sudoku now. You can see that the 3 digits missing are 2, 3, 4, and this cannot be a 4. So 4 goes in one of these cells. And coming to the rotationally symmetric box, 2, 3, 5. 5 doesn't go here, so 5 is in one of these two cells. And if you look at these two cells, it has to be 5, 7, 8. Cannot be 1, 2, 3, 4, 6, and 9. This is not 5. This is not 8. This is 5, 6. I'm just looking for cells which have less possibilities. 1, 2, 3, 4, 5, and 7. So this is 6, 8, and 9. And 1, 4, 5, 7, 8. So 2, 3, 6, 9. This is 2, 3, 6. 5, 6, 9. Right? So pretty smooth start to say the least. 4 is here. I won't say smooth start because we haven't got a digit yet, but you're getting some easy pencil markings. This is 2, 6, and 9. Okay, 2, 3, 7, 8. This is 5 and 6. 5, 8, and 9. 1, 2, 3, 7, and 4 and 6. So this is 5, 8, 9. 4, 8, 9. 4 and 6, right? 1, 2, 3, 7, 8, 9, and 5. So this is 4 and 6. A 1, 3, and a 9. 2, 3, and 4. Okay. 7 can be placed here, which could have been done right at the start. Right? 7 goes here. Seven can be placed here. Again, an easy digit. 7 is in one of these two cells. 5 goes in one of these two cells. 2, 3, and 8, right? 4, 5, 9, and 1, 6, and 7. So this is 2, 3, 8. 1, 2, and 9. 2, 3 and 9, 1, 4, 5, 7 and 6 and 8. So 2, 3 and 9. So we almost had a pair here. And 1 doesn't go in any of these cells, right? So I could place the 1 here and the 7 here. So 1 is not here. This is 3, 9. So 3, 6 and 9, right? 3, 6, 8. 5 has to be in one of these two cells. In box 5. Okay, so wherever I move now, I'm seeing 4 digits. So it's time to get onto the technique which ultimately resolves the Sudoku. 1, 4, 5, 7, 3, 6, 2, 8 and 9. A bit more pencil marking before I go to the cutthroat step. Okay, so when I was solving this Sudoku before making this video, the very first step I noticed was, of course, after writing all these easy digits, the first thing I noticed was I somehow eliminated a 6 from here, which wasn't a correct elimination, I think. Anyway, but that doesn't matter. We'll continue. Six has to be in one of these two cells. 6 has to be in one of these two cells in row 7. Okay, 8 goes in one of these two cells. 8 is in one of these two cells. Okay, so it's time to reveal the step. So if you would like to pause the video at this point and maybe continue from this point, you can do so. But this is the point where the Sudoku, where you kind of reach the point. If you don't find this technique, you're going to be stuck forever. So at this point, these 4 digits caught my eye. And I noticed that 2, 3, 2, 3, these two cells, which are, mirror images of each, I won't say mirror, but rotationally symmetric. If you rotate it 180 degrees, the cell here will just match the cell here. They contain the same digits. So I was thinking, what happens if they are different? Suppose, let's say you have a 2 here and you have a 3 here. In any order, this can be 3 and this can be 2, or this can be 2 and this can be 3. What happens is, this cell instantly becomes a 9 and this cell instantly becomes an 8, and we get some digits here. But the thing is, what happens if these are same? We have that very big question to answer. They could also be same, and there is no immediate way to prove whether they could be same or whether they could be different. So I was thinking more on that angle, and I found a really nice way to prove that they cannot be same. And I'm going to show you how. Let us mark this color yellow. And if they are same, this will also be yellow, right? Now let's watch how this yellow tracks. So yellow cannot be in here, yellow cannot be here because you have a 2, 3 here. So the yellow cell has to be in one of these two cells, which means the yellow cell goes here, right? Because it is here, so it would go here. I'm just, using the placeholder technique. I do not know which digit goes here, but I do know that whatever goes in here, it has to be here, and it has to be in one of these two cells. I'm marking both of them as yellow. Now look what happens along these 3 boxes, these 3 stacks. So if the yellow goes here, it cannot be here. So yellow is in one of these two cells, and yellow is in this cell now, right? It cannot be here because you have an yellow here, so it goes here. So yellow goes in one of these two cells. Do you see the contradiction right now? you cannot have this pattern because of the 2 and the 3 here, right? What happens is, now these cells form a kind of an X-wing. So if this is an yellow cell, this will be an yellow cell, and if this is an yellow cell, this will be an yellow cell. So in column 5, the yellow cell has to go here, but it cannot be an yellow cell because 2 and 3 are here, right? I hope I'm clear in explaining this. I know that the yellow cell goes into one of these two cells in row 2. I know that the yellow cell goes into one of these two cells in row 8. I do not know which one, but if it goes here, this will be the other cell, and if it goes here, this will be the other cell. And in both the cases, the yellow is forced into this cell, but it cannot be because yellow is 2 or a 3. Awesome, right? So if you guys found something better or sharper at this point, I'd be happy to know. Please do let me know. So I'll be interested to know what you guys found at this point. So now we have proved that these cannot be same. So they are different, which means this cell cannot be 2 or a 3 because this cell sees both this and this, which are different. So this has to be a 9. And similarly, this cell which sees both this and this cannot be 2 or a 3. This has to be an 8. Excellent, right? I mean, I wonder why this is called a glacial prism. I mean, a beautiful title for a Sudoku. Right, now let's continue. 8 isn't here, 8 isn't here, so 8 goes here, which puts the 7 here. This is 6, 9. So 9, 9, so 9 goes here, which means this is 6 and 5. This is 4, 5. So this would be 8, 9 pair. And look at row 4. These would be 4 and 5 because you don't have 4, 5 here. So these would be 2, 3, and this would be a 6. This would be a 2, 3. So I have a 2, 3 pair, which means a 9 is in these two cells. Now 7 in column 2 has only one cell left, has to be here. 1, 7, 8, 4, 5, 9, and 6 in row 7 cannot be here. So this is 6, 2 and 3. So 9 in this column cannot be here, cannot be here. So 9 goes here. These cannot be 9, this cannot be 9. And 8 has to be here now, cannot be in these cells. So that resolves this 8, 9 pair, 8 and a 9. This is not a 9, 1, 2. This is 2, 3. Two, 3, 8. 8 goes in one of these two cells. 8, so this is not 8. 3, 6 pair, so this is a 9. This is 2, 3, 6. Okay, 4, 7, 9, 6 and 8 and 2 and 3. So this is 1, 5. This cannot be a 5. This is 1, 5. This is a 2. 3, 4, 3, 4. 3, 8. This is a 6 now, which means this is 3, 2 and 6. This is 3, 2, 3. 3 gives a 4 here, which gives a 3 here, a 2 here, and a 4 here. So this has to be a 2 now. 2, 5, 7, 3 and 8. So this is a 1. All right. So you can't have a 2 here. 3, 6. This is 2, 5. This is 3, 6. 2 and 8. Right. It's kind of sweaty here because, you know, 2 doesn't go here. So this is 8. This is 2. This is 8. This is 3. This is 3. This is 6. Okay, this is 3. This is 2. And we are going to the finish now. 2 and a 5. 2, 7, 8, 9, 1, 5, 6. So these would be 3, 4. Right. So that's a 4. 3. 4 goes 4, 5. Okay, and wrappers are being thrown all over the place in utter joy. 1, 2, 3, 4, 6, 7, 8. So that's 9. And that's a 5. And with that, we have completed this beautiful Sudoku by Sulphur. What a creation, guys. Really gave me tremendous joy to find this one particular digit at row 7. I'm sorry, to deduce that row 3 column 3 and row 7 column 7 are different was really interesting. And as I said, we will try to make a video on this tri-value ordogan or Thor's hammer in the coming days. I've been researching a bit on that. I've been thinking like how to explain, and I also been thinking if I'm understanding the concept clearly. So, but the thing is that the technique is really rare and it's kind of pedantic. It's something you will know, but you will never ever get to use it until or unless someone creates it for fun. It will never find its way in any contest because it makes use of kind of uniqueness thing, you can say. But anyway, it would be interesting to make a video on that. So do remember to hit the subscribe button. We'll appreciate if you subscribe to the channel. Bye bye.